Hello there. This is going to be a relatively short video, but I think a rather important one on how to write custom probability distributions with the QPython package. So why would we want to do this is because different probability distributions may better or worse match the data in terms of the inter-arrival times at a node or for how long services take. So it may be desirable to customize these things to match the problem at hand. Let's make a custom probability distribution the way that it's laid out in the documentation of Q. So first of all, as always, import Q. And in this case, we're going to follow with their example in the docs where we're going to import the standard library random. Now, in order to create a custom probability distribution in Q, which for now we'll give the rather uncreative name of custom distribution, you have to subclass, or at least you probably should, to save yourself some work with implementing other methods, you probably should just go straight to subclassing from the distribution class found in the distributions module. And there's only one thing that you are going to usually need to override in that class, and it is intended that you do this to create custom distributions, and that's the sample method, which has to take self because we're doing an object here. We're defining an object or a class for, initializing objects later. And sorry, I'm going along with these parameters. We should explain what the parameters are. So t is time, and that's going to be the current time in the simulation. For this example, we're going to set this to none, and we're not going to deal with it, but you can make time-dependent probability distributions, which we will do in a future video. And the same thing goes for IND, which IND here is for individual, which is Q's internal name for the things that flow through the network, whether that's individuals that are customers at a business, or they could be information packets in a network. They could be patients flowing through services. They could be goods being transported or test samples being transported from one facility to another facility. So if you're into transportation networks, that's another thing you can look at. Anyway, an individual could be one of various things. And again, that may be desirable for changing how long things take. Maybe some types of patients require different amounts of time. Like if you're going to do a very minor surgery versus a very major surgery, there could be differences in how long it takes to complete that surgery. So we're going to keep it simple here. We're going to ignore time and the individual, and we are going to just say, well, I just want a custom distribution with some whatever, different behavior than what we've normally been seeing. So in this case, we're going to do a rejection type sample with a 50-50 chance. So we'll sample a value from 0 to 1. That's what the random.random function is going to get us. And we're going to check if it's less than 50. And if it is strictly less than 50, then we'll return a value of 3. So there's immediately a 50-50 chance that the returned value is 3. But otherwise, we'll return random. We'll sample another value between 0 and 1 and return that value. So you've got this kind of random switching model. If I sat down to write out the math, I expect this is a mixture model, a mixture distribution, and this is just a kind of programming representation of it instead of a convex combination. So the nice thing is we should be able to immediately use this as both or either arrival distributions or service time distributions. So let's make a quick little example just to make sure that what we've made here works. Let's define a network, and we're going to keep this simple here. Create a network, and we'll just do single class, and we'll do a single node just to keep this simple. Okay, so we'll want our arrival distributions, and in this case, we should be able to go custom distribution. And one of the things that you may or may not have noticed in previous videos, but we need to pass in an instance of the distribution we're interested in. We don't pass in just the class. So custom distribution. And we can do exactly the same thing for service distribution. Okay, I mean, that's all that it is. It's really just the same API, and that all it needed to be was an instance of the distribution class, and key to what you've added is this sample method. Let's also set the number of servers here, and let's, I don't know, generously give 10 servers. And let's do a simulation. So simulation is equal to Q, or not equal to, but, assigned to whatever the value of Q.simulation is. We'll pass in our network, which has our custom probability distributions in it. And I think the rest of that we'll keep simple. So we've got our simulation object, and maybe for reproducibility, we'll set a seed of 0. And then let's go simulation and simulate until maximum time of, let's say, 100. And let's get our records, simulation, get all records, and then let's just get a length of those records, just to show something that we've completed the simulation. There we go. So running this simulation, it processed 59 completed records and with our custom probability distribution. And in case it's not evident from explanations beforehand, you can have different distributions for the arrivals and the service. If for whatever reason we wanted another custom distribution, these are not names that I would generally recommend, but we could do something like maybe we change our switching model where there's a 70% probability of returning 3. Otherwise, it's random.random times 100, which is a very different distribution, right? And let's say that this is some behavior of there we are. Oh, you know what? Just to elaborate on this example, maybe... No, that's fine for now. We can look at more complicated examples another time. So let's run our custom distribution, which is to say that with this another custom distribution set for the arrivals, there was actually a lot less demand coming in the first place, because with, a 30% probability, you were getting these really long amounts of time, right? Whatever uniform distribution from 0 to 100, rather than the much tighter 0 to 1 inter-arrival times. So less demand, fewer records. Hopefully you find that useful as your first stepping stone for customizing your simulations to the particular problem. Of course, these distributions may very well not be the ones you need, but it hopefully shows you the minimum effort you need to put in to just create a custom distribution that is compliant with the API that you can just start using and running your simulations. So with that, I'll see you in the next video, and have a great day.